Let's talk about modernizing window apps.
All right. Hey, I'm on. Awesome. So this is probably a pretty accurate description of who I am, at least. I get paid to talk. Marius actually gets paid to do, so probably a good combination here. So I want to start with the question. Who can name one resource that you can't buy more of? Time. Absolutely. Just in case you couldn't guess, right? So I don't care how much money you have, or if you're as smart as Elon Musk or as rich as Bill Gates, right? The earth spins as fast as the earth spins. There's 24 hours in a day, 7 days in a week. There's nothing we're going to do to affect that, right? So the question is not how do you make more time, it's how do you make your time the most effective or efficient that it can be. And so when we look at why we'd modernize an app, what the right way is to modernize an app. I mean, what we're really talking about is taking something that takes a long time to get something done, and how do we make that more efficient? The cool thing is, Marius is going to really reinforce everything that I say from a theoretical standpoint with the experience that they went through, the analysis they did. But when I look at modernizing, there's like kind of a group of things that I look at from a why do something or a how do something perspective. And so I want to talk a little bit about that, so sort of the approach that we take, and what those typical approaches are, right? So everyone knows we could recode the application, right? Just take something that works one way and rewrite it and whatever the newest, latest, greatest thing is. And sometimes that's a really good choice. Sometimes you just pick it up, and I think we probably all heard this from vendors out there, just take it and move it to the cloud, right? Which is sometimes easier said than done, right? And sometimes you just move whatever your problems were right along with moving to the cloud. So, take Windows 2008 as a for instance, right? It's coming end of life, or it's already end of life. It's coming end of support unless you pay a bunch of money. What does end of support mean? It means they're now no longer going to create security patches and fixes for the operating system. So you take that 2008 and you move it into the cloud. All you did was move the no security fixes from on-prem to no security fix in the cloud. So that's, maybe not the best approach. You could containerize, and I think, by virtue of the fact that Microsoft has started including Docker technology in Windows 2016, you can see this trend from them. They thought this was a pretty appropriate way to go. And then, of course, I'm sure no one in here has a Windows 2003 server with an app still running on it, right? No one?
Guilty.
Right. I mean, I come across them all the time, and it's like, look, you heard in the keynote, this is what we refer to as legacy. Like, yeah, we still need it, but we don't put any money into it, and we're not going to do anything with it. And that's awesome, except when, again, there's those security fixes, things like that you're never going to get. So if it's something you can like totally put in a closet and no one ever has to touch or see or whatever, maybe do nothing is appropriate for it. But if it's not, you really need to start looking at what does the application portfolio look like. And so from a Docker perspective, and we actually have really good names for these things, but I'm kind of simple brain sort of guy. So I looked at our application buckets, and we have 6 buckets that we basically break applications down into. And so I simplified them by calling them no-brainer apps, right? Like there's an existing container base image and a framework and all that stuff, and it's really easy to move into a container, like stateless and all that good stuff. And then there's easy apps. Maybe they need just a little tiny bit of massaging, no big deal. And there's sort of easy apps, like, all right, we got to do a little bit of refactoring here and there. And then there's, that's a little bit complex, right? So maybe we have to rewrite pieces and parts. And then there's complex, like, all right, this thing has chunks in there we have to recreate. And then there's, wow, those ones are really tough. So what we like to do is look at, all right, of the application portfolio, what buckets do things fit in? And again, Docker has like technical names for these things. So if you look at like our MTA documentation and stuff, there's actual like smarts behind this. So what I like to add on to this is what I call weighting, right? And I've got this kind of cool acronym. I call it TRIC, but it's TRIC without a K, because I'm sure by the end of this conference, you guys are going to be sick of hearing the letter K in everything, right? So from a weighting perspective, I say, look at things like time. So what's the effect on time? Is it going to save me a lot of time? Is it going to take a lot of time to do? What's the balance there, right? And what are you trying to achieve from a time perspective in relation to your application? You got to look at risk. So is it really high risk to change, or is it really low risk? So here's an example. Let's say you have a total no-brainer application to do, but it's extremely high risk. Do you make that priority 1? Or do you do it somewhere different, right, and shift it around? So the weighting becomes critical for things like that. So you want to take low risk, no-brainers. Those are kind of easy, right? They bubble to the top. High risk, no-brainers, maybe a little bit lower. High risk, really complex, somewhere way further down in the project. Then we want to talk about impact, right? So what am I trying to achieve with doing these changes? So, maybe this is a $1 million revenue stream application. The impact is, if we can get this done, it becomes a $1.1 million revenue stream application, or something to that effect, right? So we have to understand, what's this end goal we're trying to reach? What impact are we trying to get out of doing this project? So what's the business impact, the financial impact, all of that? And of course, that leads us to that last argument, what's cost? What's it cost us to actually do this? And so I think, as we talk through the smart side of this discussion, what you're going to see is, when you look at all these things factored together, you kind of get a roadmap that lays out of how to approach your projects, why to make certain decisions. With that, I'm going to turn it over to Marius. He'll talk about their specific example of what they went through, and maybe he'll hand it back to me at some point so I could say like 3 more things.
Thanks, Jeff. As you guys can tell, we've had great leadership from Docker. We've been working on this project for about a year now, so I have a lot of exciting things to share with you guys. How many here have what you call legacy or traditional Windows apps that perhaps you're working on modernizing? Probably everybody in here, right? Awesome. By the way, thank you for attending this instead of the workshop where you're actually doing hands-on modernization. This is more exciting. So a little bit about me and why I'm up here talking about this. So back in the 90s and early 2000s, I was writing web apps in Perl and CGI, and then back in about 2002, .NET came out. Fell in love with it, and I've been using it ever since. Web apps, games on Unity, basically everything C# and .NET I've touched, both as a developer and as an architect. I'm writing a book on this, so I really dove into the internals of the kernel on Windows Server 2016, 19, trying to understand process isolation, HyperV isolation, microprocess, drawbridge architecture. So a lot of things that you may end up asking yourself, well, how does this really work underneath? I'm trying to put that kind of in a book for easy reference. That way, as you're building your apps and troubleshooting them later down, you kind of understand what's going on under the hood. Certified, so I've been Windows guy, MCP, MCTES, etc. And of course, I know you guys are hungry, so I'm going to try to make this quick, because I know we have an exciting dinner planned after this. So if you have any questions, find me afterwards. I'll be here tomorrow. I'm also doing a talk track. A little bit about Mitchell. So at Mitchell, we provide smart technology solutions for the property and casualty industry. And we basically have services for collision repair shops, auto casualty. We do workers' comp bill review, group health, pharmacy solutions, and we're slowly growing and growing. We have a wide breadth of solutions. We provide dozens of different solutions across the PNC industry. And like a lot of startups that are probably here at DockerCon, we started in a garage. However, we've been around for 70 years. So this is an enterprise that has really grown and has stood the test of time and keeps growing. So we're doing things right. And we now have over 30,000 collision repair shops as part of our network, over 300 insurance providers, and 67,000 pharmacies. We process over 100 million transactions, and these are not a one-off transaction message bus kind of things. These are very large claims, bill reviews, et cetera. And we have over $80 billion worth of claims impact within those transactions every year. So it's pretty significant. We've got office locations in the US, Canada, and Europe. And from an enterprise perspective, we have 6 data centers across multiple continents, and we manage 1,000 hypervisors. So these are hardware servers and about 12,000 VMs. So you can imagine what that looks like in terms of an operational aspect. We also have a footprint on Azure and AWS that we're continuing to grow. And we have about 1,200 technical resources from a PD perspective, ops, IT, networking. So really the main question I want to answer is, how do you manage complex products over multiple decades? And the answer really is you have to be really pragmatic about how you continue to not just operate your legacy software, but modernize it, right? And I think all of us in this room, being from a .NET and Windows background, we know that not too long ago we were dealing with monolithic architectures, right? Everything was kind of baked into one component. You're able to deploy and deliver pretty easily. And then along came this idea of a microservices. What the heck is this? What's it trying to solve? Well, luckily, microservices ended up solving a lot of issues, made us be able to innovate more rapidly. We're able to decouple and assign ownership, change our culture, and so on and so forth. But the biggest problem with microservices architecture that we see, of course, is you now have more pieces. You've got more pipelines you must handle. You have more versions of a particular service. You have interoperability questions. And moving software around can be difficult, insecure, and resource intensive, right? Same thing with actually running that software. I mentioned 12,000 VMs. You can imagine those 12,000 VMs having multiple applications per VM is probably kind of a nightmare to manage. So looking at how tools and practices have evolved to support these new architectures and new processes, we can look at DevOps, and we see that it's all built around automation and tooling, right? And the Docker Enterprise Platform is a perfect example of how you have tools that are built to support these new patterns and practices and methodologies. So at Mitchell specifically, we started picking up the microservices architecture and Docker about 3 years ago. So we started building brand new applications on microservices using SPA frameworks such as Angular and React. We started building our middle tier services on Spring Boot and .NET Core. So these are all running within the Docker container runtime, all on top of Red Hat, right? So this is brand new greenfield application development, new services, and what we found was this stuff is great, right? Once the teams understand not just the architecture, but start aligning to teams owning microservices and having their own practices around the deployment, we found that hey, we could get deployments out much faster. Daily or multi-day deployments are actually possible, right? We can innovate much faster. We can now compose a lot of these services together and create composable services that we never thought of by just kind of adding capabilities from across the enterprise. You reduce the cognitive load on a developer. Instead of having to worry about an application that has about 3 million lines of code, just focus on one microservice at a time. You've got your data domain you're focusing on, and it just reduces the cognitive load and really increases the quality of that particular service. And there's a lot of other benefits, right? And now we asked ourselves, well, what about the other 95% of our product portfolio? Just like any enterprise, we've been writing software for decades, and we have a huge portfolio of what we call our legacy or brownfield applications, right? So if you look at Martin Fowler, and what he prescribes is breaking down the monolith into microservices, right? And if you follow the best practices and approach, it all makes sense. You basically take a monolith, you identify what's most important to the business, where changes occur most frequently, you decouple it, and hopefully eventually you end up rewriting that code and you throw away the old code. And you slowly move away from this huge monolith and you break it apart into new microservices. I think even during the keynote this morning, we spoke about that, where you have the brownfield applications, where you still have your core monolith surrounded, but all new services that you're building as you're peeling off functionality. I think that's a very pragmatic approach to tackling your legacy application concerns, right? However, how long does that take? Right, so we asked ourselves that question. We said, let's take just one of our business units and let's do a quick swag of what it would take to really end up investing and moving away from monoliths into full 100% microservices architecture. For our workers' comp solution, 200 man-years worth of effort, give or take. And we kind of did this across many of our products, and we realized that, when you end up having millions of lines of code in your very complex solutions, rewriting them will take quite a bit of time, right? So that's a lot of investment. What we're doing at Mitchell is we're actually actively investing in rewriting a lot of our applications and basically peeling them into microservices. However, what we want to do is during that time that we're undergoing that journey, we want to see if we can benefit from some of these new tools and technologies in parallel with the refactoring effort, right? So what we did is we took a look at the Microsoft maturity model for kind of cloud adoption. And if you look at what they talk about is really lifting and shifting, running on the cloud, and then really refactoring your app for cloud native technologies. As Jeff mentioned, Docker has the MTA model that we picked up when we started our engagement about a year ago, which is very similar. And what you'll notice is that they all talk about the basically peeling off functionality and creating microservices, but there's a dependency that kind of belongs there, which is containerizing your application. In order to leverage new pipelines to support peeling off the functionality and to increase testability and everything, really the goal here is the thing you need to do first is to containerize your app. So we said, okay, let's go ahead and put together a proof of concept around containerizing one of these legacy applications, right? And let's see what we get out of it. Why can't we just continue running parallel VMs versus brand new services and containers? So we took an ASP.NET IIS app, and this is a 2005, 2006 era-ish app, right? Started in .NET 1.1, 2.0, and it's kind of, we've been upgrading it, keeping it up to date. We're now in .NET 4.7.2. However, the base core frameworks and architecture styles are from the WebForms era. So this is kind of a WebForms type application, runs on IIS. So we stood up an IIS container on top of Windows Server Core, and we deployed our application there. Next thing we did is we refactored some of the components of the application. If you look at architecture practices from the early 2000s, you'll find that the apps were built with a lot of config baked in, whether it's in app settings or web config or INI files that were carried over from even legacy back then. And they're just kind of full of this bloated configuration and a lot of other issues. So we decided let's refactor the app and spend just a few weeks worth of time to identify what are the things that we need to do to pull out, like configs out of the app and really externalize them. That way, when we create a container, we have a truly multi-tenant container that can run in any environment, and we could just inject the configuration inside of it. At Mitchell, most of our applications not only run multi-tenant, but can be dedicated to a particular customer. So it's very important that all of these things are externalized. And we also created new parallel pipelines. That way we could iterate and test. And as we learn more, it'd be easy for us to take this application, not only push it to our existing VM infrastructure, but also push it onto a parallel container platform. In this case, it's a Docker Enterprise platform. So by having parallel pipelines early, we were able to quickly iterate, and as we learn lessons, we're just able to push out new containers. Now that we have a running application, we've proven that we could run our legacy .NET application inside of Docker. We wanted to measure the potential impact that this would have if we were to apply this pattern to the rest of our product portfolio. We chose to go with an APM provider, so instead of just leveraging out-of-the-box logs or just going with like an ELK stack for high-level logging, we wanted to dive deep into the code and really understand line-level, production-level metrics, right? So as the code is running production, what does each line of code do, and where are the bottlenecks? So APM, for those of you that don't have a solution, really it's application performance monitoring. These are tools that you basically add onto your app and they start instrumenting your application. Whenever you have issues in production, they'll catch them early and often, and they'll create baselines of expected application performance. Whenever thresholds are kind of passed, they'll call out errors and create tickets and all kinds of cool stuff for you. So what we did by injecting app dynamics into our application, we were able to compare both the VM hosted version of our app and the container version of our app. And the reason that's important is because when you take an application that has an old architecture, you're going to find that you have some practices that may not work very well with containers, right? A lot of heavy disk I/O locally occurring on the VM or the container versus perhaps an opportunity to externalize some of that caching to like a Redis cluster or something like that. So it's very important for us to really just understand where some of the issues were as we started moving to containers. And also APM allows us to leverage the machine learning capabilities built into APM solutions so we can use them for smart orchestration. So as we get more mature with the platform, we could spin up containers and anticipate load if we know we have spikes at certain times of the day or certain days of the month. This is just a screenshot of what APM looks like in our environment. So once you inject the APM into the app, it automatically discovers all your nodes, all the data flows. It tracks basically the call times. And at the bottom, you could see there the response time, load, number of errors. And here, talking about brownfield, you can see how we have monoliths. And as we're starting to break it apart and create services, you can see the data flow out to more and more services. So as this architecture becomes more complex and more microservices are involved in the entire application lifecycle, you're able to trace issues much more quickly. So taking that into account and knowing that we now have APM and we have some sort of risk reduction there, if we know if something is misbehaving, we started redirecting some of our load in our test environments. So we had some load go to our Windows IS VMs on our traditional hypervisors, and then we started redirecting some of the load to the Docker cluster. So rather than just using the Docker enterprise cluster as our primary ingress point, we decided to make it a subnode, if you will. Right? This way we could pull the plug at any time, and we're able to easily add more or less load as we saw fit during our testing. What we found was really interesting, right? So on the same exact hardware, we were able to get almost twice the throughput in a container versus of a VM. That was kind of interesting for us. We did not expect that type of performance, right? So we wanted to really understand why are we getting so much more throughput on IIS inside of containers versus a VM. And that's when we started thinking about, well, you know, on VMs, you have hypervisors, you have guest operating systems, you have a lot of kind of layers of abstraction and overhead, whereas in a container platform, even if you're doing the HyperV container model, that amount of abstraction that you have is really reduced significantly. So we did some quick back of the napkin calculations, and taking into account that one of our standard VMs was about 8 gigs worth of RAM and 2 cores per hypervisor, we realized that 64 gigs out of the 256 gigs per blade that we had were really wasted on overhead for the guest OSs. So this is RAM allocated to the operating systems that are running at that layer. So a quarter of the RAM was kind of wasted. And then we did the same thing for disk space. And we realized that give or take 20 gigs per VM on that machine was wasted disk space. So 640 gigs or half a terabyte per blade was wasted for redundant Windows images, swap file space, et cetera. Now, if we were to look at what happens inside of the file system of a container image, you'll see that once you build an image, you can reuse that. So even though the base Windows IS container image is something like 10 to 13 gigs worth of size, if you build your stacks correctly, that's reusable between all your container versions. So you pay the cost once on your blade, and then basically those instances are spun up and they don't have any additional costs. So you have a potential just right off the bat savings of over half a terabyte worth of space per blade there. And when we're talking about 1,000 nodes, that's significant amount of cost reduction when it comes to, you know, enterprise level storage. And finally, CPU. We got back about 3.2 cores worth CPU by reducing the kernel overhead and those sub-hypervisors that are kind of just doing rudimentary work that, you know, is no longer needed as you move to containers, because you have a single process that's running isolated with a few Windows services to enable the functionality in HyperV mode. And we also wanted to see how much faster could we spin up additional capacity. Using our standard VM setup, we basically saw that it took about a calendar week to get a new node up and running. We had some human interaction. Yeah.
So you are saying that it was almost 10 containers
Absolutely. So yes, you could run 10 containers within the same space that you could run one VM, because you get a lot of resources back. And if you think about the size of a web applications and their needs are small. And now imagine you're throwing away 2 gigs per web application for the overhead of the guest OS. So depending on your architecture, it could be a 10-to-1 in terms of, yeah. Yep. But really what matters in our test is the throughput. And we saw almost 200% throughput for the same exact hardware. So, yeah, absolutely. And I think this morning they mentioned, what was it, 40% more throughput on average or something like that. As we move to Docker, we noticed that once you have this set up, it takes just seconds to spin up a container and get it running. What's cool inside of Microsoft 2016 and 2019, if you use the HyperV Isolation mode, they actually will create a very lightweight utility hypervisor, and they'll basically get it warmed up to the point that it's almost ready to go, and they'll snapshot it. So when you run your container, what they do is they actually load the snapshot of that container, they inject your container inside of it, and they start it. So it literally takes seconds once you have everything up and running to spin up your container inside of that utility hypervisor. And it's all done under the hood, you know, this is happening, but it's really cool stuff, so it's pretty optimized. And again, almost twice the throughput for the same exact hardware. So now that we know there's a good potential for some good ROI, next thing we wanted to find out was, can we run all the cool new things we've been building on Spring Boot, Java, right, and .NET Core, run that side by side with our legacy apps that we're now modernizing, and have one universal control plane to control everything, right? Can we make operations of all of this easy? And so what we did is we took Windows workers, created Swarm clusters, and had them managed by the Docker Enterprise platform. And we took Linux worker nodes, and with Kubernetes management, we did the same thing. So now you can run Linux and Windows side by side managed by one UCP control plane. And this is where I'm going to hand it off to Jeff to talk a little bit more about the architecture.
So I hope by the end of day one, no one needs explanation of what Docker Enterprise platform is, right? Any show of hands? No one wants me to go in deep on this, I'm hoping. All right, so I'd say some of the key things to take away from this is the enterprise platform is like that wholly integrated solution, right? But there's things that are not provided by Docker that are not prescriptive that we don't include in the platform. So you get, the Trusted Registry, and you get the engine, you get that security integration and all that good stuff, and of course the GUI to manage it all, universal control plane. But when you start looking at the application ecosystem, that application performance monitoring piece that Marius talked about is really critical. And that's what's so cool about that is, yes, you can use it during this porting effort and it goes to watch your application performance, but that can be tied back in. So now it's watching the performance, but it can do things like scale your application automatically because it sees the response time or the number of connections or whatever metrics are important to your application. So there's great hooks back in. You guys happen to choose AppD. We don't care which one you choose. We can integrate with just about anything to make this work. That's the beauty and the flexibility of the overall platform, is we can give you a lot of really cool recipes and ways to do things, but we don't tell you what you have to buy to make all this stuff work. Of course, as we start talking about the pipeline and putting applications, this is where Docker Trusted Registry really becomes an important integral piece of this workflow. Part of taking those legacy apps and what you want to get out of them is the ability to stuff them into a CI/CD pipeline, right? And have them move automatically, in automated fashion, as Marius talked about, move them automatically through the way you could never do before, right? So you commit your code change and you end up with a container at the other end that can run in production. DTR is really important in this process because it can do things like the security scanning and image signing and so forth. And so it becomes an integral piece of how that pipeline runs, but again, it's not prescriptive. We don't tell you. You saw an example this morning in the keynote where we can now, or coming up really soon, do a pipeline init and up pops a Jenkins file, but it doesn't have to be Jenkins. Because we connect in via a series of webhooks and API calls and so forth, you can integrate any CI/CD platform into this mix. So you create an environment where, again, it's tailored to your business and the way it works, and it's really loosely coupled together. And of course, as Mario showed you their environment, they have all these different application zones, right? All these different application groups, different application types, and those things, we can limit those in what we're calling secure application zones. Really, it's multi-tenancy within the Docker environment. So that lets you capitalize on that investment rather than, one cluster and one infrastructure for a specific team's workload. You can start logically dividing that up inside the cluster environment and grant access to only those resources that are required for that team to work. So again, capitalizing on the investment, being able to spread it out over multiple tenants, really makes it a lot more efficient.
Thank you. Right, so at this point, where we're at is we're actually looking into how to expand this further. Now that we have a Docker cluster up in our data center, we want to see how can we leverage this investment to continue expanding the modernization effort, right? One of the things we want to do is to move to a cloud a little bit more, potentially get some savings by changing how we do DR. So one of the things we're doing is we're looking at actively right now, we're working on this, we're building a secondary cluster in both AWS and Azure, and we're using the DTR replication to basically move our images. As soon as you have your pipelines publish and sign and push your images into your local DTR copy, you could have it clone out into a copy running in a different cloud provider. So now you suddenly have this built-in DR capability where your images are now copied over to multiple providers, and if a specific cluster goes down, whether it's your data center that you manage or one of the providers, once you have that smart load balancing layer in there, you can actively shift your workloads from running from one data center to another. You probably have questions around, Microsoft applications usually running on SQL backends. How do you enable that? We're looking at using AOAG for this, where we have an active cluster, whether it's on-prem or in a cloud provider at any time. And then when you fail over the entire leg. But given how containers work, we know that we're able to spin up capacity and workers in seconds. So as long as your AOAG replication and masters fail over properly and you have an entire setup there, you should be able to fail over to any of the providers and have your full workloads go there and have running within literally seconds. And this is, again, just another view at the pipeline. You have your traditional apps that are now being containerized. Containers are being built. They're signed and pushed into your secure registry. Same thing with your brand new applications, whether it's Spring Boot or .NET Core. They're pushed to DTR, and then DTR just kind of synchronizes with its other members on the different providers. So really DTR becomes kind of the base repository for all of this code that's ready to run at any time within a container. So what were some of the lessons learned during this POC so far? So again, legacy applications have legacy patterns that you really want to review. Question?
When you talk about DTR replication,
yes.
DR part, you were only talking about DR for the registry, or you were talking about DR for the
For the entire application. So when I was talking about DR, was I talking about the registry or the entire app? So the answer is the entire application as a whole. The beauty is, instead of having to let's say snapshot an entire VM and move that over the wire to a secondary data center, right? All you have to do now is really, once your container is built out of your pipeline, if you snapshot that and copy it to that secondary DR, it's now available for that cluster to use. So imagine I have a lot of Windows worker nodes using a local DR cache here, and suddenly connectivity drops. If I intelligently route my ingress to that secondary data center, it has everything it needs to basically work, right? You have some workers that are spun up, idle most of the time, and as it starts sensing traffic, it just will spin up the appropriate number of workers to accommodate the load. It has its local copy of images, so it has everything it needs to run. And again, by using SQL AOAG, if you're a SQL shop, and you have the constant data replication, you just fail over the primary node, your primary write node to that data center. So now your application is working with this local copy of AOAG, well, basically almost no refactoring required for this legacy app to take advantage of this architecture, right? So really, with a small bit of investment and looking at your application, doing a few things such as removing configs out of web configs, app setting, or INI files, and trying to externalize that, whether it's environment variables, an external config service, or some other pattern, allows you to have a really clean container that you can easily basically spin up in any environment, and you just inject all the variables, the database, location, et cetera, right? Simple, but a lot of folks may not think of this. Your web app needs to have a shared backend session store if it's an IIS app, right? So at a minimum, using SQL as a backend and not using in-memory session store. Hopefully nobody's doing that in 2019. GMSA. So the way the .NET applications interact with network resources, such as CIFS and TFS file shares, et cetera, is a bit different because they're not part of a domain. So we use the group managed services account to basically proxy access requests into network resources. So again, this is something that you kind of need to step into. Not a lot of organizations are using GMSA. So this is a perfect opportunity to understand how it works and how it allows your application to reach and access those sensitive resources. Getting security involved early is very important. Containers are a new concept, and a lot of security organizations have some homework to do to understand how you can apply and meet your security requirements at your organization, right? So even though the Docker Enterprise Platform comes in with CVS, security scanning, and all other goodness, it's really up to you to build in the appropriate pipelines and ensure security is met. Training for existing resources is a must, in my opinion. Again, this is a brand new paradigm, and it's not just up to, let's say, your developers to go and build microservices and adopt a new architecture style. Really, everybody needs to be involved and really treat this as a cultural shift that involves everybody understanding the tool sets and the patterns together. I'll start out with the POC. Again, assign a team, let them play with it, have them prove the value out, and kind of create a center of excellence or champions that can lead this, right? This is a shift that takes a while, so it's good to start with the focus team that has that kind of, their charter set to do exactly that. Automate early, like I mentioned, parallel pipelines are a must. I know we all love to kind of jump and experiment and skip some of that stuff, but being able to create a pipeline where you can easily try new things and you have this pipeline automatically pushing out your containers is great. It saves you a lot of time and it saves you a lot of headaches when it comes to troubleshooting. And adopt a container orchestrator, right? When we started our journey with Docker over 3 years ago and we decided to use it for our new applications, we decided to kind of build our homegrown orchestrator, and once you get to the hundreds and then eventually thousands of containers that you have to manage, we come back to the same problem we have with 12,000 VMs. It just becomes really difficult to manage. So making sure that you choose an orchestrator, whether it's Docker Enterprise Platform with Swarm underneath or something, it's really make sure you have that in place. It just makes life easier as the complexity of your environment grows. It allows you to plug in things such as APM to scale your containers and being able to warm up new containers and spin them up and so on.
So Marius, can I ask you one thing?
Yes.
So obviously it hasn't been 200 years of effort between when we started this effort and now. So all those lessons learned, all these things that you stumbled through, now that you've solved them all, like if you look at an application that's traditional .NET, can you talk about how much time roughly it takes, you think, to take it from its form and put it into a container?
So if we have a developer that's well versed with Docker, right? So they have, let's say, a few months worth of hands-on experience. I'd expect them to spend maybe 2 to 3 weeks per IIS application to get that thing in shape in terms of refactoring the code, adding new patterns, practices, et cetera. So we're talking about 2 to 3 weeks worth of investment, and then I'd feel confident saying this is an app that's ready to run on a container platform. If you take probably, let's say a dev that's never played with Docker, maybe add a week or two to that. And at maximum, I'd say any dev, given a month, they'd be able to take a legacy app of, I'd say average complexity and containerize it and run it on a platform.
All right, thanks.
Right. So thank you, and I think we have just a minute for questions.
We have 1 minute left for questions. Well, I think the last session ended late. We started a little late, so.
There you go.
Yeah.
There's no one beating down the door.
Perfect.
This is the last session, and
yeah.
let's take a couple of questions.
How are you?
Hi, doing well, thank you.
Good, good. Can you talk a little bit more about the configuration journey that you guys did?
Yeah, so configuration really it's interesting. The goal at the end of the day is to have a container that does not rely on anything that's embedded to determine how it needs to connect to the outside environments. So everything, whether it's URLs or database locations or secrets, should all be injected into that container when you spin it up. And what we chose to do is to use a microservice that we had built specifically for configuration. So upon startup, with environment variables, we basically tell the application, this is the URL of that service. You can also use a database if you'd like a SQL database, and you give it the info, and then it basically goes to that specific, whether it's a service or database, to pull all the other information it needs to start up, so the bootstrapping time. One way you could do this is by overriding a lot of the built-in app managers that are part of the .NET framework, and you could basically roll your own, override the interface, and just have it connect out to your database or even your microservice.
Okay, so you're talking about dependency injection in .NET Core when they set up the configuration part? Is that
Well, even in pre.NET Core, there's the app settings that you could override. So when you do app settings.connection, you could override all that and basically redirect it to a local cache that gets warmed up during bootstrap time by going out and pulling that configuration. So as long as you have a small initial piece of information, such as this is the URL and some extra info, you can bootstrap all those settings and inject them and basically cache them locally for your app.
Thanks.
Yeah.
Anybody else?
That one's back
Here in
there.
the middle.
I think you mentioned a little bit earlier, but HyperV isolation versus process isolation. What did you guys decide was the best way to run your containers, and performance-wise, what did you notice in benefits of one versus the other?
So I specifically love the idea of HyperV isolation. So when you do process isolation, the main OS kernel is shared with the underlying containers. When you do Hyper-V isolation, basically they make a copy of the kernel and they run a very small, lightweight copy of that kernel within a small utility Hyper-V. So you get 100% full isolation between the main kernel and the underlying kernel. So when it comes from a security standpoint, I think that'll give you the best bang for your buck. And in terms of overhead, very minimal difference in terms of overhead. It's that Hyper-V they built is specifically optimized to run containers, and it's a very shallow copy of the main kernel. So it doesn't do any extra kernel activities like a full VM would. So we did not notice much significant difference in terms of performance between the two. Yes. Yeah.
Man, I'm glad you could hear that second follow-up question. Whew, I'm getting really old.
Yeah, the question was, were the benchmarks based on Hyper-V isolation? Yes, they were. Yep.
So you had mentioned using GMSA accounts
Yes.
within these containers. I'm just curious how you're accomplishing that. So your containers are actually joining Active Directory and such?
No, so our containers, when they reach out to fetch sensitive, let's say a network file share, right? We're using GMSA on the Docker layer to proxy out and basically, what's the right verbiage for this?
So basically the way a GMSA works, the worker node is in the same group, the same DN as that GMSA account. So your Active Directory resources, right now they're governed by a group or a user, that SID or that GUID that goes along with that. A GMSA basically extends that. So you set a security context for the container, it reads that SID, that GUID, and then the container itself is able to use Active Directory authentication for resources in there. So it's not like your application suddenly becomes Active Directory integrated or Active Directory aware. But let's say, you've got a web front end that's talking to a SQL Server backend, and that SQL server is using AD authentication. Mm-hmm. Instead of an SA account where you're hard coding, like a user access account for that database, you use the group managed service and grant that group managed service access in the database engine. So the container, as it pops up with that, is able to negotiate its connection to it and use that.
Yeah, so your application isn't really aware of all this, right? So your application thinks it's running an admin account perhaps that's local to the container, and it's not part of a domain, and it attempts to reach out to a resource outside of its boundaries. GMSA kind of takes place, and it'll translate that request into an AD account, a GMSA account that can then access the resources.
But if that account has to be installed on the, I'm thinking in a traditional sense on a Windows server, that GMSA account has to be installed on the operating system. Is it somewhat impersonating like the host?
Yes.
So the GMSA account doesn't get installed on the operating system, but what happens is you create the GMSA account in the AD tree, right? And then the worker node, again, has to be in that same group, that same DN within the Active Directory environment. And then you just pass those credentials basically into the container. So the app, it's like a container never joins a domain, right? Yeah. Because they're transient, they come and go, wreak havoc on AD if they did. Yeah. So it's basically just like a user level authentication, if you will.
Yeah, so it's impersonation. Yeah. Thank you.
Okay, we've got two more here.
Just a quick question to continue along the same theme. If I have a large monolithic app and I've given the container the group managed service account rights, how does the app sort of have its individual functions restricted?
Sorry, I did have a hard time here.
Yeah, I couldn't really hear that.
If I have a large app, right? Correct me if I'm wrong, but if it has multiple components, and in the past I may have assigned individual security rights to the functions of this app. How does that sort of translate into like the Docker where I've given the container?
So like you're talking like if you had a monolith where everything was just kind of working together in that one application versus breaking it apart. So there's a lot of different options how you approach it. But the beauty of having things in containers is you can connect things either through sockets or through network connection, but as far as containers go, as you start breaking them apart, you can make them appear to be running on the same host. So they negotiate with each other the same they would on a host. The only thing you're really injecting is instead of like a local function call, it becomes a network function call, right? So you're reaching out to a URL instead of a function specifically. And so that's that kind of recoding, refactoring stuff, is figuring out, which function are you going to separate out to be its own little piece, and then you call that one separately. And so each one of those that you start to function out becomes a microservice, right? And that's sort of how they start to relate. Once you've got them separated out, then you can start separating across, bigger boundaries. So not on the same host, but wider.
Now, again, I believe, during the general session, they spoke about the different class of legacy apps. You have true legacy, where you have no further investment you want to put into it. You containerize that app, and it can live there forever if you have no need to truly refactor it. And then you have really the brownfield apps, which are apps that you're continually investing on, right? So these are your classic legacy.NET apps, and they're probably going to live on for another 5, 10 years or even longer. These are the ones where you want to actually invest to refactor and really peel away functionality and build microservices. So you start out with perhaps a single container, that's huge. And as you start rewriting functionality, you start having more and more containers that run through their own pipelines and their own life cycles. And then you could start getting those benefits of why we're doing this entire thing, which is, again, more agility, faster time to innovation, being able to compose multiple services together to create new functionality. And, at Mitchell, having 1,200 plus tech resources, really providing a lot of services across PNC, over time as we've grown, we've noticed that, some business units may do something better than others. So we can easily now start shifting the areas of expertise, if you will, and have different groups focus on different things, such as, core bill review platform that's now shared by multiple products and so on.
So I think we're sort of getting the hook here.
Let's do one more question. Quick one.
Yeah, he answered.
Oh, I guess you just answered her question.
Oh, excellent.
So how about if
Let's do one more.
we'll jump off stage and you guys we can talk right after this?
Yeah, quick question. Is it possible to run an app pool NIS under a Windows domain?
To run an app pool NIS under a domain user?
Yeah.
No, so again, this is where GMSA would basically step in. Whenever that app pool would need external resources, GMSA would impersonate that external access. So the app pool would run under a local account, local to that container, not part of a domain.
But then you'd be able to, if you need to get out of something as you would run normally as an AD account, then you'd be able to do that with a GMSA?
Yeah. Yeah, so when that app pool tries to, let's say, access an external database, the GMSA would impersonate that request.
Awesome.
Yep. Thank you.
All right. And thanks everyone for
Thank you all.
the session.